You guys can hear me at the back? Thumbs up? Awesome. So we're going to be talking about avoiding big balls of mud with serverless event-driven architectures, something I'm super passionate about for those who know me. And it's actually surprisingly easy to do, and I guarantee most of you have probably fallen victim to some of this we're going to be speaking about today. Last year I was here in Manchester doing a talk in the other room, actually around the same time. And I started off by saying this in the first slide, which is that event-driven architectures are actually becoming more accessible. You hear the words, the buzzwords come up more and more. Then architectures aren't anything new. In fact, there are books going past 20, 30 odd years ago talking about message-based architectures, right? But there are services out there that are helping us. So for example, we have Lambda. Who's using Lambda? Let's get a feel of the room here. Of course, most people, right? Serverless compute, being able to trigger something based on some kind of event, right? In the middle, we have Amazon EventBridge, one of my favorite services. Hands up if you're using EventBridge. Cool, nice, awesome. That's grown since last year. So yeah, being able to trigger events and have downstream targets and consume is fantastic. We have DynamoDB streams, being able to listen to real-time information here, and API gateway and all sorts of things. In fact, when we take a step back and actually look at the market at the moment, there's even other open source projects coming on board. Again, we have like trigger.dev, ingest, hookdeck, some of the folks here doing some awesome things in this landscape. So event-driven architectures are just becoming, as I said, more and more accessible to us. And it's an interesting thing because when we start to build event-driven architectures or look, does that flash or is that me? Look and we design our systems, you can see we have boxes and we have things and we have channels and we start to actually put things on these. So we have a producer, as an example, here is a publish, subscribe kind of relationship. So we have a producer and then we have a channel and then we have downstream consumers. Okay, which is fantastic. And when we start building event-driven systems, this is what we do. And in fact, we go to the whiteboards and we keep going, and your teams will come along and say, we need more channels. We've got SQS, we've got whatever it is, step function, SNS, EventBridge, Kafka, RabbitMQ, all sorts of weird and wonderful things. We get all this awesome value from it. In fact, we keep going. We just say, we need to raise another message or another event. Okay, we have AWS here to provide all these cool features for us. So here we have different domains. We have like payments and orders. We start to use at the bottom here, send invoice email. We start to use events as commands. We start to understand what is an event, what is a command, even what is a query. We're talking about messages. But anyway, we keep going, we keep building our architecture back to the whiteboard, we pat ourselves on the back, we keep going and building this system, okay? This event-driven system. And on paper, we say, yes, we are decoupled. Of course we are decoupled. We're resilient. We have a loosely coupled system here. But in fact, what we realize over the next 6 months or a year or whatever it is, you actually end up in this weird big ball of mud scenario. In fact, that complexity lies within the details between these boxes. Right? That complexity nurtures this weird relationship between big balls of mud. Now, if you don't know what big ball of mud is, it's actually coined from domain-driven design. And there's a paper that goes back to 1999 by Brian and Joseph here. I don't expect you to read all of this. There's a fantastic thing on resources at the end if you want to dive deeper. But when I was putting this together, I noticed there were a few things that stuck out to me. Number one is unregulated growth, okay? Information is shared freely between boundaries and between systems. And the structure of your system may actually never have well been defined or structured in the first place. And it's interesting because with event-driven architectures, especially service event-driven architectures, when it's giving out, they give so much out of the box, so easy to fall into this mentality. With unregulated growth, let's just raise another event, let's just raise another message, let's add Kinesis or Dynamo or whatever it is. Here we have information shared freely across. I'm raising an event, I don't know who the consumers are, but you can have anything you want. Okay? Our system wasn't actually designed in this particular way in the first place. is there anything in domain-driven design we can use to help us manage this big ball of mud? And after like 6 or 7 years diving into this whole ecosystem and talking to many enterprises and customers, I just got to the point where I truly actually believe that without guardrails, governance, discoverability, and defining the event architectures, you will end up in some big ball of mud. Okay? And I'm super passionate about this, and I see people making the same common mistakes. So my promise to you in this talk is actually to walk away with some guardrails you can put in place. Think about how you could structure your event architectures to avoid that complexity and avoid this mess. That's what we're going to be talking about today. So number one, how complexity kind of fuels big balls of mud when we're talking about event architectures. Number two, what 3 guardrails you can put in place after this conference in your organization for your customers and your architecture. And number 3, the one thing I'm passionate about most actually is this ultimate catalyst, this ultimate problem that I see many, many people fall into when they build event architectures, and I'm going to share that and how you can get around this. There'll be a summary at the end of all the slides, all on GitHub, everything I'm talking about, so feel free to sit back and kind of relax. So, before I get started, who am I? I'm Dave Boyne. I previously actually, I was a developer advocate on serverless at AWS, recently left to basically do more open source work for the community. I'm super passionate about that, so I actually spend a lot of time in event architectures and write tools around event-driven architectures. On the other side of the fence, I am also a developer advocate at Wing. Has anyone heard of Winglang before? Curious? Cool, couple of people. There's a brand new programming language actually we're trying to make for cloud development. Okay, some really cool stuff. I might be biased here, but if you're interested in any of that or seeing a new programming language for clouds, come see me after. I can show you some demos and things like that. But yeah, as I said, I like to dive deep into this stuff. I've been doing this stuff for many years, and I like to just share what I learned along the way as I'm speaking to a lot of people. So first of all, is like how complexity itself fuels this big ball of mud that you'll see. Okay, and a few years ago, I went to my first AWS reInvent. Has anyone, hands up if you've been to AWS reInvent? Cool, you know, about 10 people. If you ever get the opportunity, I highly recommend it. It's absolute chaos. 50,000, 60,000 people walking around Las Vegas trying to learn what AWS has to offer. So it's very bizarre and chaotic, but I highly recommend it. That year, Werner Vogels, the CTO of Amazon, was on stage doing his keynote, as he does every year. This year was a special year, for me anyway, because he'd done a whole stint on event-driven architectures. I thought, wow, the time has come, let's go, let's rock on. And I watched the talk, which was good, and he said one thing that stuck out to me. He says that systems that don't evolve will die. Okay? That kind of got me thinking about systems I've worked on in the past, and companies I've worked in, and architectures that I've built and been part of. I kind of distill in 2 main areas here, especially when we're thinking about event-driven architectures. It's this idea of static architectures, things that kind of hold us back, or things that slow us down, things that might be coupled. Okay. Now the interesting thing about the static architecture, and I've definitely seen people do it, and I've definitely been there. The thing about static architectures, we don't go off and design it to be like this. It ends up like this. On the other side, we lean into event-driven architectures to build evolutionary architectures, be able to evolve our architecture over time using messages that have this decoupled mindset. And it's an interesting thing when you even dive deeper into this, is kind of, where does it all start? And I'm about to tell you the most scientific thing you probably hear in Manchester all day, is that knowledge increases over time. Thank you. It's an interesting thing. Okay, knowledge increases over time, that's fair enough. So why is it when we build our applications and our systems that all the decisions are made up front? Yeah, we know what architecture we're going to use, we know what services we're going to use, we know the domain, we know the problems, all this kind of weird stuff. You end up in this weird place. Well, okay, are we actually building what we need and what we need in the future? And this actually has a word, this actually has a terminology. It's actually called the project paradox, if you want to dive deeper. But the project paradox, I believe, has this weird side effect of this risk of building these architectures that feel static in nature, okay, and kind of slow us down as an organization. And we have to get the things, we have this pressure to get everything right up front because we have to build it like this. Static architectures, they're just characteristics. There is no such thing, I guess. But here are some things that you might associate with. Tightly coupled systems, hard to make changes because if we change this, we're also going to change 3 things down here. Low cohesion, so maybe our services, whatever it is just doing too much. And again, it's hard to make changes. The one that infuriates me the most down here, and again, I've been in teams before, is this resistance to experimentation. We can't use that new AI LLM model as an example. We can't do this because it just costs us too much, because we're just so coupled and it's hard to make these changes. And then team interdependency, well, okay, we have to make some schema changes, some API changes, but we need to talk to John and this team. He needs to make some changes over here, but then Janice on this team needs to then publish the changes, but all it is just one line of code. So what's happening here? As I said, we don't go off and build architectures like this. These architectures lead to this weird frustration that technology itself becomes this weird burden in an organization. Earlier this year, I read a report, a Gartner report, okay, and it was quite an interesting one. But they said that businesses are placing emphasis on speed and agility, okay, 60% here. And this was earlier in the year, and I think it's probably more now as we can increasingly do more and more with AI. Is anyone using Cursor IDE at the moment, or any of this stuff? A few hands. Be able to just rapidly build prototypes and projects. It's fantastic, actually. So we have this emphasis on this, and let's go back here. We have this risk of this weird and wonderful architecture styles. So what happens if we just use event-driven architectures and actually defer the decisions? Right, have this evolutionary architectures that we can build, loosely coupled architectures, and this is probably why you're here today or why we're using this stuff, enabling incremental change. Evolutionary architectures and event-driven architectures tend to have these promises that we're loosely coupled, okay, easy to make changes. We have this high cohesion, we're doing very small things and doing it right. We have the dream of platforms to experiment, okay? Being able to lower that barrier to entry, and we can listen to events and experiment more. And then team dependencies, if we just use events to communicate across boundaries, across domains, as an example. And it's an interesting thing. I'm pumped for event-driven architectures. As I said, I just dive deep into it a lot. I'm fascinated by this architecture style. I think event-driven architectures lead to innovation within a company, reduces the barrier to integration, as we can just consume an event that's already been raised. Fantastic, maybe an event-rich event as an example here. So it's fascinating, I don't know, when we compare these two architecture styles, we lean into event-driven architectures to help us. And there are many, many benefits to this distributed style, especially as a serverless style. There's one fundamental problem with event architectures, is in fact, they actually increase complexity. Okay, there's this weird and wonderful world where you see this complexity actually, as I said, is the fuel for this big wall of mud that you'll see. And let's talk through an example, a serverless example here, of how this starts. So here is a very, very basic architecture diagram. We're using event bridge in the middle to send some events. We have an order service. This could be Lambda function, ECS, doesn't matter. We have downstream consumers. We are placed today here as the order team to raise an order-placed event. We have heard that we can do this stuff, and we read some books, and fantastic, let's go. We as the team go and look at the schema for event bridge. So we decide, okay, we have the detail type, the order placed. Okay, that's fine, that's fair enough. Pretty good naming conventions. We have the source. The source here tends to be the domain. It could be whatever you want. We're using it as a domain, myapp.orders. Again, pretty good practices. Down here, starts to become interesting. So we are tasked with the envelope of our message. We have the order ID and the user ID in there. The order has been placed. Okay, What's wrong with that? Nothing. So we go, we raise an event, everyone is happy downstream. Next, 3 months, 3 weeks, whenever it is, we have the next one. The order is cancelled. So we've done this before, we copy and paste a message. We go back here, we can just raise another event onto the event bus. So we do that. Here, we have a reason. Okay? As you can say here, ordered the wrong cat food. Why was the order cancelled? Well, we have a reason. Why have we added a reason in the message? Well, downstream consumers may want it. Okay, so emails, you cancelled your order because of this. Okay, there might be some value in it. We have a type, NPOW, meow. So us as a consumer starts to think, this is pretty weird. What does NEOW mean? In fact, to the order service, they know what this type NEOW actually means when you cancel an order. But us as consumers now start to wonder what is happening here. Why are there cats in the event? But what's happening here, in fact, is actually implementation details are leaking in our events to downstream consumers. Is this a problem? Who knows? Down here we continue, we have the user. This time the user is an object. Last time we had the user ID, now we have a user object, it has the ID in it. Fair enough, that's not a problem. We have first name, last name. Okay, should downstream consumers get this information? Is it PII information? Don't know, don't care. We've got this mentality of just raising messages in events because the barrier to entry is actually pretty low. We continue, we have order updated event. We start doing CRUD events, all sorts of weird and wonderful things. So again, we start building our architecture, our serverless architecture. We have Lambda, right, raising events into Event Bridge. We have downstream consumers and API destinations, fantastic actually. We have step functions, orchestration, for our business workloads, or even containers. Great. We continue to scale this out. We have more Lambda functions, we have more APIs here, more events firing off. We introduce SQS for whatever reason, and things are looking great, I guess. And again, time goes on, we have more and more here. We introduce S3, we introduce Kinesis down here for data streaming, fantastic. So many people look at this and probably think, okay, things are getting complicated, but in reality, all serverless architectures are doing is bringing these architecture styles up so we can see them. So in fact, this is actually pretty standard serverless event-driven architecture. But why is it, again, in 6 months, 12 months, that we start to see this weird and wonderful thing that we have, with this big ball of mud start to appear? And as I mentioned earlier, it's this weird complexity that starts to creep in between the lines. Complexity comes in these two models. We have the essential complexity. Your domain is naturally complex. There's nothing getting away. There's no getting away from that. If you're doing banking or whatever it is, or policies, life insurance policies, there is essential complexity. But at the top here, we also have accidental complexity. This is where you see many, many things and problems start to emerge when you're building these event-driven systems. And complexity is an interesting thing because complexity, again, we don't start off by saying we're going to build a complex system. We start off by saying we're going to build a simple event-driven system. Here are 3 nodes as an example. Here are 3 different channels. That's it. 3 nodes, 3 channels. This could be us talking after this. This could be us at the pub. This could be microservices or events, whatever it is. We add 2 more nodes into this mindset, into this thing here. And now we have 10 different channels of communication. Okay, we only had 5 in the first place. We continue to build upon this. We continue to build our architectures, and now we have 7 nodes, 21 channels of possible communication. You can just imagine as this thing grows, how complicated things can get. So when we talk about serverless, what do? Well, we lean into the services to help us. We lean into Event Bridge or SQS. We introduce policies. You cannot talk to this. I am controlling this through different mechanisms. Fantastic. So we start to build this event architectures. And in fact, going back to basics again, Lambda, event bridge, Lambda. So we look at this and think, how complicated can this be? Well, as I said, complexity lies in details. First of all, what is the domain? What is the first Lambda? What do we mean by this? What is this thing actually trying to do? Second, most often overlooked thing is schemas, event strategies, schema definitions. What is it inside your payload? How do we manage this thing going forward? Again, things that are often missed is how you consume events and messages, right, can couple you directly back to the implementation. So there's complexity everywhere, even across boundaries, even across Lambda functions, even across domains. What language are we using? What is a policy? What is these ubiquitous language that we need to define in this architecture? So you end up in a weird and wonderful world when if we don't think about this, this complexity in this big ball of mud starts to creep up. So what can we do and what can we put in place to help us? There are 3 guardrails here. Number 1 is understanding behavior versus implementation and the differences here. 2 is actually an event strategy. What do we mean by different event types and the trade-offs there? And equally, I mentioned earlier about that coupling strategy. What can we take from domain-driven design to help us build this stuff? So first of all, was an interesting one, was like behavior versus implementation. So when you start to implement a system or understand its behavior, when you start to build event-driven systems, you start to end up in this weird and wonderful place, especially as the services are given to us. Event bridge, how easy it is to raise an event and add a Lambda consumer as an example. You probably get it set up in 5 minutes. So we start to do this, you start to see this incremental value, this value up front. Fantastic, we're using these services. Look at us, we're awesome, this is great. We have our producers and our consumers, and we're making waves here. Down along the line here, we have adding consumers and more producers over time. So our architecture is growing. This is what we want. This is an evolutionary architecture approach. But you'll notice that value tends to kind of plateau over time. That value, that initial bump that we got, tends to kind of disappear. And why is that? It's the complexity itself in event-driven architectures rapidly goes up as you start scaling your EDA solutions. We have the initial producers and consumers, as you can see, more producers. We have to start thinking about dead layer queues, resilience, idempotency. What happens if the event is played more than once? We have wrong boundaries and unclear domains. We've not even thought about this system as this architecture as a whole. So again, discoverability becomes a big problem. How many events, who's consuming what? Issues again start to arise. And this is like fundamental implementation first, hands-on, let's get going. Now what happens if we just stop for a minute and take a step back and actually think about behavior? And this is Alberto, he's the author of Event Storming. And he says an interesting quote here, is the developer's misunderstanding that gets released into production, not the domain expert's knowledge. Okay. And for me, this is fundamental. It's actually taking a step, especially as we build EDA solutions, and thinking about behavior first thinking. Think about what happens if we actually take a second to understand the behavior of our system. What happens if we actually collaborate with domain experts and people, and how that can help our event architectures. As we collaborate, we can identify messages, identify events, commands, queries, if you want to keep going that way. We start to define a language that is used and can be used in our event architectures, between our systems, in our messages, in our schemas. Becomes interesting. And hands up if you've heard of event storming or modeling before. Cool, so about half the room. So event storming is event modeling is a way you can actually workshop, and you can do it with people in your organizations to actually start to identify some of these boundaries, these events, these commands, these messages, this language that you can use. You can transfer this information into your serverless event-driven architectures. And the key really here is to just share that knowledge between your teams. Here is a basic example I'd like to share. Here is an example of like a car park solution. So as you drive up, you take a ticket out, and then I can also extend this later on in the future using a mobile app or whatever else. So most people probably haven't seen this before, but I guarantee most people in this room can probably understand what is going on. If we map this to a serverless, event-driven architectures, we have create a new ticket, the command. The command in our event architectures can be rejected. This is a synchronous request. We can use API gateway for this. Fantastic, maybe Lambda under the hood. When we create a ticket, maybe it's DynamoDB in this case, we can create a stream or whatever it is to say the ticket has been created. We can raise this event on event bridge. Down here we have car park spaces updated. So if we're updating some DynamoDB table, as an example, we can have a stream that listens to this and raise another event. What I'm getting at here is event storming is a great example to actually think about our domains, think about boundaries. On the left we have car park, parking sessions, expire sessions. So we can start mapping this domain itself and take leaves from domain-driven design and actually implement them in our event-driven architectures to help us just gain structure and organization around what can be, probably what will be chaos. So the first takeaway here really is just consider it. Consider that behavior first thinking. Think about, can we do something that can hopefully help us in the future? So I recommend just thinking about that rather than diving straight in up front. The next one here is about event strategies. Very often overlooked. What do your schemas look like? Versioning your schemas, notification, event carrier state transfer, delta events, all sorts of things, weird and wonderful. You start diving into this, you get lost. The interesting thing about event strategies is APIs versus events. APIs, we've been building APIs for tens and tens of years. You go into any enterprise organization, you say you want to build a new API, okay, where's the Swagger docs, where's the purpose? All these weird and wonderful governance things and tools that we have in place. With events, for some reason, we don't have any of this, or a lack of this. And it's an interesting thing, because modern applications have both events, APIs, tables, state. Events tell a story. We can use events to tell a story, super powerful. For example, I got up today, what did I have for breakfast, what did I do, did I walk in, did I get a taxi here, what time am I going home? All these things are events. Think about your applications, your customers, your users. Think about what they're doing. Think about your product owners, your CTOs, your CEOs. Everyone's interested in data. What is happening? These are events, they're immutable facts. This thing could happen. We can use Event Bridge as an example to do this. We can start using data lakes and all sorts of weird and wonderful things. Events tell that story, which is fascinating. Tables, on the other hand, tell us the state right now. So query me right now. I am on stage delivering this talk for you all. Your applications will have both state and events. When we start to lean into events more and more and more, we start to see this. How do we version events? Okay, so first of all, you probably think, okay, well, most people just YOLO it and start raising events and come to this later on. But think about how do we version? So you think, okay, yeah, we're going to use server versioning, non-breaking changes, awesome, fantastic, good for you. Great, that's a good option. But now let's scale this out. I'm talking to people at the moment who literally have thousands of events in an architecture. So how do you manage versions across these things? How are you going to know who you're breaking? But remember, as you're building event architectures, you are told you don't know who the consumers are. So how do we get around this? And the answer really is there's no one option. But there are options and trade-offs to consider. Number one here is like backwards compatible. We are always going to be backwards compatible. It's our governance, it's our strategy. Our events are always going to be this. We are not going to make any breaking changes. Sounds simple, but I'd be curious to know who in here has had these conversations around their event schema design. Optional new fields. If you're adding new fields, make them optional. As an example, is a perfectly good strategy. Down here, parallel versions. I am going to raise version 1 of this event on Event Bridge, and now I'm going to raise version 2. You have a deprecation date, whatever that might be, or you can start some way tracking consumers and kind of migrate them over. Different strategies. Now, if you go into the ether and you start talking about schemas and all this kind of stuff, you'll see this quote come up, this law come up, right? So the Postal's law says, be conservative in what you do and liberal what you expect from others. And I think this is great to an extent. I think if you follow this with the serverless event architectures, there are trade-offs to consider. And let's have a look at an example. So what we mean by being conservative in what we do, so we're conservative in what we send to our downstream consumers. We have the order ID and we have the user ID. We're simple. This is actually called a notification event. We're notifying the ether that something interesting may happen. Consumers may be like, okay, I'm interested or I'm not. That's not up for us to decide. So we just raise an event. Fantastic. Being conservative, being liberal in what you expect from others, what we mean here is, well, if you're getting a payload, as an example, a bigger payload, I'm only going to validate the fields I'm interested in. So if things are breaking, it doesn't break us because we're not validating everything. Fantastic. So most purists would say this is a great solution. I'm not quite sure when it comes to serverless architectures. If we have this, let's go back to this. We are raising this event, this order and user ID. Okay, good job. And I've done this in the past, and there's any interesting side effects that may happen. What you'll often see is your consumers will say, thank you very much for this information. Now I need to go and get the information. Okay? So what happens is they go back to the order service and say, I'm going to use your API if you have one. If not, I can just connect to your DynamoDB database or your shared database where things start to happen. I was in an organization once where we did this. I was using EventBridge, just come out 2019, building this kind of system, seeing all weird and wonderful back pressures. But it's so easy to fall into, especially as time goes on, because you have more and more consumers coming out. You don't know who the consumers are. Again, querying for information, putting back pressure onto the service. Now, you might look at this and think this is a real bad architecture decision. But in fact, there are benefits to this too, right? So if your consumer needs up-to-date information, where is it going to get it from? It's not too bad to go back and fetch it, okay? But I think just make these decisions consciously. Don't be caught out in the future as I was in the past. The other alternative to this is we raise events with all the information in the world. Okay, event carry, state transfer, bigger types of events. You can do this at EventBridge. Great, this is fantastic. I personally like this kind of model. But again, trade-offs to consider. So now, if we're using EventBridge, we can actually start doing input transforms, transforming payloads before they get to downstream consumers. We can start doing filtering based on events. I'm only interested in orders that are over £50 as an example. Start doing some interesting things. The side effects to this, maybe, are we introducing eventual consistency between the things? Okay, so the service at the top, thank you very much, I'm going to store this information. Fulfillment service, I'm going to store this information. So now, the data will eventually be consistent, but there are times where it's going to be out of sync. So what have we just introduced to our customers or architecture? So there are things to consider here. Again, not one is better than the other, but these are things we have to think about. And we have to put the effort in to think about these and define and think about just your event strategy, your schemas, your messages, what type of messages can help. Here we have the last one, managing domain models with event consumers. So the interesting thing about event-driven architectures is we can fire events off into the future, consume them, and if I today was to fire an order placed to you, you are by default a conformist to my model, okay? What I mean by this is I have orders, I have that cat thing, the type, whatever, the implementation details. I'm throwing it to you, you are the payment service, and you start to consume this. And that order model, that order properties are all over this code base. So what have we done? We have coupled back to the model. We're decoupled on paper, but we're coupled in implementation. So the interesting thing here is that, again, that might be okay, it might not be, but what options do we have? Well, we can use things like anti-corruption layers. So we take your model, your payment placed, or whatever it is, your order placed, and we map it into a domain that we understand. Now, EventBridge offer a great solution for this using input transforms. Okay, we can actually map something into something for downstream consumers. Other options, open host service. These are bounded context mappings from domain-driven design, but open host service means we push back onto the producer and we say to them, no, we agreed a contract up front, we had that discussion, and this is what you're going to send me. You are going to map it into our domain language. Okay? These are things we don't think about. These are things that are not very well documented on some of these services and as we build these solutions. So the question is, which one should I use? Well, trade-offs again, but it depends on the level of communication that you want. Conformist, I'm going to make a change, I need to talk to you to make the change. Okay, we have this high level of communication between us. Open host service is we've agreed up front, see you later. Please don't break the contracts. There is this domain-driven design community. There's loads on there, like 15, 16, or whatever it is. I highly recommend just, again, spending time and energy just to look at some of these things. Can really help you avoid complexity and mud. Here, there's also one other thing here is actually understanding the change in complexity between distance of components. Okay, interesting thing that kind of creeps up on you. If you're doing EventBridge and you're doing multi-account topologies, as an example, you do multi-bus topologies, which is a great thing to do. You have different bounded contexts, different things, different accounts going on. You have something called private events, which I like to think of as, and public events. Now, under the hood, we're still using Lambda, EventBridge, SQS, whatever it is, the same technology. But the context is completely different. Private events here on the left is we have Lambda and EventBridge, but that type that we had, MEOW, we all understand that because we are the order service. We understand implementation details. So raising events with this data inside of it is completely fine. On the other hand, we're raising events into a central bus. The central bus is going to other teams, other organizations, using API destinations as an example. So completely different. Your schema strategies, your evolution strategies, everything is completely different. The contracts are completely different here. So what I recommend here is just thinking about these three things. Behavior first thinking, defining your strategy, and then that coupling strategy there. Okay? And finally, there's one thing that catches a lot of people out all the time. And it's actually a reason I left AWS to focus on this as an open source tool. But the thing is here is we have this big ball of mud, we have this architecture, we've done our things, you've promised us, and things are looking okay. We have this serverless architecture, fantastic, and we feel embraced and empowered. But there's one saying when you look at event architecture, one thing that will get you and it can come all crashing down, I believe, and I've seen lots of times, is this. Is that we say that producers do not know about consumers. Okay, we say we publish these events and consumers, we don't know who they are. Fantastic, we're decoupled by nature. This is a problem. Common questions start to arise. You see often, over and over again. New person joins the team, what events do we have? Oh, I don't know, there's a GitHub repo, go figure it out. Okay. What are the payload of the events, by the way? I've been tasked to do something, and I think we have an event somewhere. What are the payloads? Using Afro, JSON. I told you, go figure it out. Cool. So, by the way, who's consuming this event? Who's consuming what? I'm about to make a breaking change. I don't know what's happening. Again, these things at the start are easy. These things, as you scale, become super complicated and super hard. Luckily for us, we have open specifications and open source free software you can use to help. So is anyone using cloud events, out of curiosity? Cool, 2 or 3 people. Cloud events is a specification you can use to define your schemas. Why this is really cool is because if we look into the future of event-driven architectures and streams and channels, we need a common way to communicate between boundaries and organizations. Cloud events is just a specification that allows you to track some of this, okay? Async API, hands up if you heard of this. Go again, 5 people. Async API, I used to work on this project. Async API is a specification that allows you to document your channels, your servers, allows you to document your messages. Okay, you as a service, what messages are coming in and what messages are coming out, what events. Okay, and Async API allows you to do this. Through this, we have specifications, and from specifications, we can provide tooling. Tooling here, as an example, is one thing I'm focused on at the moment. Has anyone heard of this? Just curious. Cool, one of 5 people. So Event Catalog is something I'm doing. It's free, it's open source. I spend a lot of my passion into this problem space, just to help people in this area. Event Catalog, what it allows you to do, it allows you to document your event architecture. It allows you to bring discoverability to architectures, or using Markdown, visuals, and all sorts of things, owners. Who is using what, answering these questions? Who is doing what, answering these kind of questions? Visualizations of services, commands, queries, and events, and all sorts of things. You can do all of this just powered by Markdown. Again, I'm a super geek when it comes to this. So many people have this problem, so I'm actually just diving into this and helping people out. There's integrations you can use. If you're interested, you can come and join our community, but use EventBridge here, OpenAPI, Async API, all sorts of things you can automate to your heart's content. If you want to join the community, again, I'm just doing this. I enjoy this. If you want to join us, feel free to join the Discord channel, the contributors, and you can see here we have almost about 17,000 created. And I honestly just believe that to manage that big ball of mud architectures, put these guardrails in place that can really help, and just bring the discoverability to your architectures. I can't tell you the amount of conversations I've had in the past, especially with enterprises, especially as you scale, you start to have these problems around discoverability and problems that you often see. And with that, I've got a couple of minutes, just want to summarize here, summarize this talk. As I said at the start, event-driven architectures are becoming more accessible. We're seeing this buzzword keep coming up over and over. We have SaaS providers, people actually investing in event-driven architectures. It's fantastic to see. We go away and we build these serverless architectures because it's good and it can provide us lots of value. But equally, we come to a grind, and you will come to a grind at some point when you start to see unregulated growth freely using events and this free of information. But you can control this. You can control that guardrail, that complexity, just by thinking about these things. Behavior-first thinking, event strategies, and that coupling between them. And then here, equally, we have, and I honestly believe putting guardrails, governance in place can help you build these systems. If you want to learn more, I have visuals here. It's a free book. I've got like 80 different visuals of things that you can read and check out, so feel free to grab that. And all the slides, everything I spoke about is here. And feel free to grab me after this talk if you've got any questions. And I appreciate your time, and sorry if I've run over a couple of minutes.